Hello. Good morning. Welcome to Science E-Learning Academy. My name is Malaki. In today's tutorial video, we shall be looking at the micrometer screw gauge and how it can be used to measure length. In our last video, we treated the vernier caliper and we saw how we can use it to measure length. And we said that the micrometer screw gauge measures length with a very high degree of accuracy. How is this so? If we want to measure length of this magnitude, if we want to measure length of this magnitude, let's say so an accuracy of 0.001 cm, the micrometer screw gauge can help us take this type of reading. And the micrometer screw gauge takes accurate measurement of very small length. If you can see now, if we want to measure the diameter of this ball, the micrometer screw gauge can help us do that very accurately. Now, how does the micrometer screw gauge work? The micrometer screw gauge has two sets of scales. It has the main scale, and this is the vernier scale. This is the main scale and this is the vernier scale. And to make measurement using the vernier caliper, you have to check for zero error. Look at this. Before you make measurement, this is the ratchet. You have to tighten this such that the zero of this vernier scale corresponds with this line. You have to tighten it such that when this thing meets, this thing needs to close up. Then you notice that the zero of the vernier scale, this is the vernier scale, corresponds with this line. When you have ascertained that, then you can go ahead to make your measurement. So let's say if you have a ball like this, you want to measure the diameter of this ball. So what do? You take the reading of the main scale, then you add it to the vernier scale. This gives the reading, the measurement of this ball. Now we are going to solve some examples to illustrate this. So we are going to bring out the main scale, and bring out the vernier scale all joined, and we take the reading of the main scale and add it to that of the vernier scale. And I have said before that the micrometer screw gauge can help us make measurement of length that is up to this accuracy, 0.001 cm or 0.01 millimeter. So let's see how we can make measurement using the micrometer screw gauge. Before we solve some examples on micrometer screw gauge, now let us look at this ruler. This ruler is calibrated in centimeters. And the smallest measure of this ruler is 0.1 cm, and that is the reading accuracy of ruler, which is calibrated in centimeter. And what is reading accuracy? Reading accuracy is the smallest measure of an instrument, as we said in our last class. So how is it 0.1? Look at this. From here to here you have 10 small lines. Counting from here. If this is 0, counting from here, you have 1, 2, 3, 4, then 5. You keep counting, 6, 7, 8, 9, 10. You have it up to 10 small lines, and this is 1. So if we divide 1 with 10, we're having 0.1, and it's in cm. So the smallest measure of this instrument is 0.1 cm, and that happens to be the reading accuracy of the ruler. So we are going to employ this in solving problems involving the micrometer screw gauge. Now let us look at this diagram. The diagram, in this case, I will say the diagram above. This is the diagram. The diagram above shows part of a micrometer screw gauge. What is the reading? So this is the main scale. Let me write it. the main scale. This is the main scale, and this is the vernier scale, the vernier scale. The main scale and the vernier scale. All right. So how do we go about to take the reading? So if this is the main scale and this is the vernier scale, we are going to add the reading of the main scale plus that of the vernier scale. Adding the reading of the main scale and that of the vernier scale, what do we then have? So if you look at the main scale, it is calibrated in millimeter. Usually the micrometer screw gauge is calibrated in millimeter. So how do we now take the reading? To take the reading, if you watch this, just as we did in when we were taking reading of the roller, if you look at this, this is 0. So let's count how many small lines. We have 1, 2. So we have 2 small lines and we have it at 1. So how do we now get each of the lines? That is the line in between 0 and 1. So if this is 1 and this is 2, I'm counting the lines now. So and we have 1 here, so it will be 1 over 2, which is 0.5. So meaning that this small line is 0.5. Let us check if it's correct. If we count 1, 2, 3, 4. If we multiply 0.5 by 4, it will give us 2, which is what is here. So it means that each of the small lines is 0.5. So how do we now take the reading of the main scale? So the main scale reading now will be, this is 4, and if you look at this correctly, you have another line here. So it will be, this is 4, and since each of the lines here is 0.5, it will be 4.5, and is a millimeter, say 4.5 millimeter. So we have taken the reading of the main scale. So then now let us find the reading of the vernier scale. This is the vernier scale. To find the reading of the vernier scale, we check where it coincides, where it meets this line, So how do we now check it? This is 5 and this is 10. It means that this is 5, 6, 7, 8, 9, 10. Each of the small lines is 1, 1. Each of the small lines is 1, 1. So if we, let's check it again, 5, 6, 7, 8, 9, 10. Yes. So to get this line, if we subtract 1 from here, this will be 4, this will be 3, this will be 2, this will be 1. So this will be 0, 1. So at this point is 1. So you have 1. And how we do it is that you now multiply it by the reading accuracy of micrometer screw gauge. The reading accuracy of micrometer screw gauge is 0.001 cm or 0.01 millimeter. But since this is calibrated in millimeter, usually there are some micrometer screw gauge that you will see and it will be calibrated in cm. So in that case, the reading accuracy becomes 0.001 cm. But since this is in millimeter, we are going to take the reading accuracy of this instrument to be 0.01 millimeter. And what do we say is the reading accuracy of an instrument? The reading accuracy of an instrument is the smallest measure of that instrument. So since we have gotten this point, the vernier scale, where it joined with this line, since we have gotten it to be 1, let us multiply it by the reading accuracy of this micrometer screw gauge in millimeter, which is 0.01. And we now have 0.01 millimeter. So if we add 0.01, if we add 0.01 plus 4.5. We are having 4.51. So we're having 4.51 millimeter. And you see that this option B is correct. 4.51 millimeter. So the reading accuracy of an instrument is the smallest measure of that instrument. And for the micrometer screw gauge, to take the reading, you add the reading of the main scale plus that of the vernier scale. Now let us solve the example below, the question below, so to to see if this procedure works. Looking at this problem, you see that the main scale reading here will be um, this is 5. This is 5. What will each of the small lines be? We need to check very well. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So mean that each of the small lines will be, we say 5 divided by 10, and it will be 0.5. So the small lines are 10 and we have 5 here. So when we divide it by 10, we have 0.5. So meaning that each of the small lines is 0.5. And we have another line here before the 0 of this vernier scale. So it will be the reading of the main scale now. Main scale reading will be 5.5 and is in millimeter. 5.5 millimeter. So what are we now going to have? You need to find the total reading. You need to add both the main scale and the vernier scale. So the total reading will be that of the main scale plus the vernier scale. So we have gotten the main scale to be 5.5. Then plus, let us solve for the vernier scale. To solve for the vernier scale, you check where a line in the vernier scale joins that of the main scale, and it is at this point. So if you check this line, this is just looking at this from here to here has 10 small lines. So this is 35. So meaning that each of the small lines is 1. So this is 36, this is 37. So it joined at 37. And what is the reading accuracy of micrometer screw gauge? It is 0.01 millimeter. 0.01 millimeter. So that we multiply it by the 37, and we have the total reading to be now 5.5 plus, if we multiply 0.01 by 37, what we have? 0.01 times 37, we are having 0.37. Remember, all is in millimeter. So the reason why we multiplied 37, which is what we got here, by 0.01 millimeter, is because this micrometer screw gauge is calibrated in millimeter. So we need to take the reading accuracy of micrometer screw gauge in millimeter and now multiply by the 37. So we have 5.5 plus 0.37. So what we have? We have 5.87. We have 5.87 in millimeter. Look out, if you watch how the units are written, usually separated, so don't mind it. So 5.87 millimeter is the answer. So meaning that option C is the correct answer. So let us solve this. What is the reading of the instrument below? What is the reading of the instrument below? This is the main scale and this is the vernier scale. Of course, this is 15, 16, 17, 18, 19, 20. This will be 21, 22. So before the 0 of the vernier scale, this is the vernier scale, is 22 millimeter. 22 millimeter. So we add it to that of the vernier scale. So this is 30, 31, 32, 33. So this is 33. We multiply by the reading accuracy of micrometer screw gauge in millimeter, which is 0.01 millimeter. So if we multiply 33 by 0.01, what do we have? We have 0.33. We have 22 plus 0.33, and now we have 22 plus 0.33 will be 22.33 millimeter. So this is how reading is being taken using the micrometer screw gauge. You add the reading of the main scale plus that of the vernier scale. Let me revise it. Going upwards. This is the main scale and this is the vernier scale. So if this ball is tight the way it is when you screw this is the racket, so that it gets fitted in like this, you take the reading of this main scale and add it to that of the vernier scale. So that's how reading is being taken using the micrometer screw gauge. Please, if you find this video very interesting, subscribe to our channel, uh, comment, share, and invite your friends. My name is Malaki. Thank you for listening.